Howdy, and welcome to Iceland. We are in Iceland. We are looking at 7 days earthquake activity. And there is quite much activity. But we want to check out this patch of land here. The most recent, probably, which some of you might remember, Bardabunga, 2,000 meters high. Eruption in 2014. And there has been some quakes in recent days, 4 days ago. And if we go south, here in the middle is Grímsvötn, caldera, dormant. Grímsvötn is Iceland's most frequently active volcano, probably because it is located on the center of the active northeastern rift zone of Iceland. Most of the volcano is hidden beneath the giant glacier of Vatnajökull, Europe's largest glacier. That's massive. So I went to take a look. There's other volcanoes. There are all over the place. Esjufjöll, Þórðarhurna. Yeah. What kind of words? And here we have a glacier. So we have to assume that that's somehow volcanic, since there's like another volcano here, Öræfajökull. And this glacier looks like a fish bone, in a way. And it has certain features. Not only does it have these streaks here, which go in this direction of where it's flowing to, it has also these. Some probably would call them year rings. But since we are in a volcanic region, Iceland, we have to assume that this has to do something with the glacier. As Grímsvötn is told, it's under the Europe's biggest glacier. What if that's a contemporary lava stream made out of water, and those features here are the impulses or pulses when it's, how to put it, not degassing, but it's fluctuation of the water pouring out of the mountain. It has a certain frequency. Sometimes it might be longer, sometimes shorter. So, a quick, simple recap. This is the glacier we were watching. That's a volcano. Somewhere here was the glacier, and somewhere here, all over the place, are volcanoes. There are probably many more, but they're not just on the map. So, let's go to the Alps. Try to remember the features of the glacier. Obviously, there's quite much going on still in Europe. I probably got my paper now finally finished. Hopefully. So I might have time to make some videos again. I don't know. Is anybody waiting for them or not? It's just a warning. I'll probably make more often again videos. Or I continue with my other paper. But anyway, Chamonix, we are in the middle of the Alps. We have some action going on here since quite some time. That's just 7 days, but this has been going on for quite a while. Yesterday, 3 days ago, Here we have more than one quake and a very interesting geological feature. Can I turn it around a little bit? One, two, three, four, five, six. Six quakes at the exact same spot. And what a spot we have here. I don't know exactly. Are we looking at rocks? Or is this a glacier? Or probably this ice? But the quality isn't that well. So we probably might never know. We could also go to over the Google Earth and check it. I have been thinking about that. I didn't do it yet. The reason why we came here in the middle of the Alps is this one. Glacier du Takul. Check this out. Similar feature. Year rings. And there's also this very interesting feature which seems to widen, but it's in a way continuing the whole way as long as you can see, as long as you can follow. Here it makes a turn, and here is something going on. I bet, I mean underneath the glacier, like rivers, maybe glaciers could be fed by aquifers along the way to the valley. I think so. So there's probably not just one single source for the glacier, but several along the way. Here we have some lakes. There are several of them. They're all over the place. If this would be only meltwater, we could have expect many more of these what is it? Lakes. 17 kilometers in depth. Rather deep. So we have this glacier here, with this very distinct feature of year rings. And they continue until the end, in a way. Here we have this kind of feature, and somehow the glacier stops here. There is no ice in this place. So is there a possibility that under here we have an aquifer? AF, aquifer. And the glacier continues. And here you can see still the features. I don't know, I really would like to go there, check it out by myself. Go to hike, take a bike. Grotte de Glace. Glacial cave. Yes, I just wanted to show you here. You can go inside, I guess, somewhere. Check it out. Yeah, this blue line, actually, that's a water vein. Let's just see where it This one is just originating out of the mountain, as is this one. And it's also here doing the same, just emerging out of the ground. Here, it's drawn until here, but if you follow this up, you can see this spot here, which might be just a glitch in the matrix, or it could be this kind of wet spot where water is emerging and it takes the sediments away, as we probably can see here. This might be very well water pouring out of the mountain. And if this region would be in a permafrost region, hence it would be like cold all year round, there would be growing a glacier. So I leave it up to you. Make your own decisions about the origins of glaciers, what they really are. I think they are contemporary lava streams made out of water. Hence the mountain. The glacier carrying mountain is a volcano, which will erupt according to its cycles or the amount of energy induced into Earth's electric circuits, and many other things. But it's still active because there is a glacier. And there is water pouring out of the mountains, which is energy flowing out of the mountains. And in order to prove that it's energy flowing out of the mountains, that there has to be a circuit. You can imagine all the dams which got built, and hydroelectricity dams got built there, and they are getting electricity. They just transform the energy of the water into electricity. They harvest it. They harvest the mountains. If there wouldn't be any energy or something to harvest, you wouldn't gain electricity. Because if there is nothing, you get nothing out of it. There has to be something in the first place in order to harvest it, at least to some degree. And I think those patterns here on the glacier are signs of the eruptive interval of this alpine volcano. What we see is the water flow in form of ice and its pulsations, fluctuations. As we have seen in Iceland in the beginning of the video. So I just made this picture for everyone to compare those two. I think there might be much better examples, hence which have much more similarities than just these two. But I stumbled across these two. Iceland and Switzerland. Glaciers with similar features. And there are glaciers. So probably it's time that we have to rethink the whole nature of glaciers once again. But I leave it up to you. Make up your own mind. Thanks. Bye.